Good. So again, thanks everyone. We're excited to have Mitsubishi Electric Trane HVAC present at our first Passive House Components Spotlight. They've been a great supporter of Passive House as a whole, as you guys know, and they were one of our first founding sponsors. So they plan on discussing a few innovative products, but also, as they do, feel free to ask questions, put them in the chat. We'll take a good look at them and make sure that we get all the questions later. It'd be very similar to kind of the happy hour where we'll get to all the questions and we're not in a rush, and we'll make sure we get to them. It's also going to be recorded so you can see a lot of it later, which will also be helpful. And it will live on the site as well as on our YouTube channel. So we've got three speakers. First is Kimberly Llewellyn, technical lead performance construction team. She's a lead on that. She is a certified Passive House consultant, specializes in low load buildings and IEQ. We have Chad Gillespie, senior project manager of the performance construction team. He's been and continues to be a dedicated supporter to Passive House and energy efficient programs. We've got Dan MacCollum. He's the regional commercial manager, New York City metro area. Dan works with engineering and architecture community on both proper application of Mitsubishi HVAC products, and his team are also actively supporting a number of Passive House projects throughout the area. They have a deep understanding of the needs of these buildings and the challenges posed by local law 97. So again, if you've got questions coming up or have questions that are even unrelated to what they're going over, feel free to put them in the chat. They're all here, so you get to just jump right in. Here you go, guys. Go for it.
Okay, great. So actually, Chad's going to start out. I'm going to hand this over to you, Chad.
All right. Thank you, Kimberly. And hopefully everyone can hear me. I want to thank everyone for being on today. Thank you, Michael and Zack, for having us. It's pretty exciting for us as a company, as we have, as Michael has said earlier, we have been a supporter for quite some time. We love Passive House. We love everything that every one of you has done, all the work and the effort. We've learned a lot about our equipment from Passive House, and we truly believe in the future of Passive House because we know the importance of our future with energy, our environment, and we know this is a big part of it. So I just wanted to thank you as our team. We really work hard to encourage builders to build to a higher level and to the ultimate level of building Passive House. So thank you again, and I'm going to pass it over to the smart people, Kimberly and Dan. So thank you again, everybody.
Thanks, Chad. So I do want to thank Chad more specifically because he hired me onto the performance construction team almost 4 years ago. And it's, you know, I was working at a mechanical engineering firm in Austin, and I loved the work that I did. But I also felt like I wanted to have a broader reach, and Mitsubishi has provided me with that platform and that opportunity to get onto the other side of the table. When I was an engineer, I took the stance of, darn manufacturers, why can't you come up with the products that we need? We've been asking you for 10 years, like, where are they? And, you know, when I really thought about that, I thought, you know, there's probably a reason. So I'm never going to find out what that reason is or what I might do to influence the product development process if I stay on this side of the table. So Chad provided me, and Mitsubishi has provided me with the opportunity to get onto the other side of the table and to bridge some of those gaps. So really, I'm grateful for that. So I am the technical lead for the performance construction team, and as Michael said, I'm a certified Passive House consultant through FIAS, which means that I give a lot of trainings both internally and externally. I support our commercial team a good deal across the country, and we're trying to get all of our sales team a little bit better versed as to what is involved with passive building standards so that they can better serve you and your projects. I additionally sit as a voting member on ASHRAE 622 and 227P committees. So 227P is a passive building design committee, which is in development. That's meant to be a standard, which could be adopted by jurisdictions who are trying to figure out how to make their Paris Climate Accord goals come true. So more on that, maybe at some other time, but it's going really well. So all of that is to say that I think and live and breathe this stuff. If you have feedback for me or for our team as to what we can do better in terms of expanded performance data, coming up with tools to make your energy modeling or inputs easier, always open to product requests. We're here to listen to you. So again, this is really to say we still have a lot to learn, but we understand the needs of passive buildings pretty well. We understand that you've been asking for lower capacity equipment for a long time. We share the same concerns as you about high GWP refrigerants. And we know that with our lower sensible load buildings that we start seeing a reversal in sensible heat ratios in our spaces, which means that we have to do better with latent control of dehumidification. I'd like to hand this over to Dan. He's going to tell you all about a new host of products that we've got coming out really soon, which address all of those requests. It's not an end game, it's not an end point, this is an evolution, but I think we're all really excited about what we're going to be able to provide you with really shortly. So with that, Dan, take it away.
Great, Kimberly, thank you for the wonderful lead-in, and just reviewing some of the responses from the polls. One thing that sticks out at me is it looks like the majority of people who are tuned in are working mainly on single family or multifamily projects. So fortunately for the multifamily people, it's pretty much all I'm going to be talking about are products that will be a good fit for that type of application. Single family folks, though, please don't hesitate to ask questions and we will do our best to get to everything that we can. So these are the products that I'm going to talk about. It's kind of a hodgepodge, this slide, but first we're going to talk about right in the middle, the hydronic or hybrid VRF system. Then we'll move on to, I guess, the highlight of the day, the CO2 domestic hot water heat pump. And then we'll touch on a couple new indoor units that we're going to be releasing in the near future. So the hybrid VRF system, I'm going to make an assumption, and I could very well be wrong, that everybody on the call at least has an idea of what VRF is. So simply put, this hybrid system is what you would be familiar with on the heat recovery side of VRF as it stands today, with a big change at the BC controller. So no longer does that BC controller simply accomplish heat recovery and act as the refrigerant flow traffic cop for the system. What it does now is it has integral heat exchangers that transfer that energy from the refrigerant circuit into a hydronic loop that connects to hot water, chilled water fan coil units. So simply put, those two refrigerant pipes that you see connecting from the outdoor unit to the BC controller are the only refrigerant pipes in this hybrid VRF system. Everything from the BC controller out is all water piping. So we're going to run through some of the key advantages for this hybrid VRF system. And in bold, underlined right at the top, no refrigerant in the occupied spaces. So if you've ever been involved in an ASHRAE 15, ASHRAE 34 refrigerant concentration limit calculation, as long as you can place that BC controller in an unoccupied space, you're not piping any refrigerant into the sleeping quarters or living quarters for anyone. So there no longer is an ASHRAE 15 concern for that system. What that also will do is allow us to utilize larger VRF systems than we have been able to in the past. Typically, the limit for a VRF system size is a function of the smallest connected indoor space, not the actual capability of the equipment. But now, since we're not running so much refrigerant, or piping refrigerant to an occupied space, the utilization of larger VRF systems is going to be more achievable. If you're familiar with VRF, you're familiar with the quietness of these systems, and these water fan coil units are, believe it or not, a little bit quieter even. So your whisper quiet VRF system becomes more of a soft whisper quiet system with HVRF. And for those of you like me who are concerned about the global warming impact of these type of systems, even though there is refrigerant still inside the system, it is substantially less than a traditional VRF system. And there are so fewer brazed connections, which can ultimately be failure points in the system. The likelihood of a leak is drastically reduced as well. A few more benefits of this system. I mentioned before that there's less brazing. You also get the benefits of a 4-pipe system in terms of simultaneous heating and cooling with only 2 pipes. The defrost cycle happens a little bit quicker than with typical VRF systems, but in our climate, defrost, at least in my experience, hasn't been a very challenging aspect to work around. But then lastly, intuitive load adjustment. That's just a fancy way of saying that this system is fully variable. So the refrigerant flow can vary, the water flow can vary, the fan speeds can vary. Everything will move and track to hug your set temp as tightly as possible. On the servicing and maintenance side, it is, in my opinion, a nice benefit that all of the valves, pumps, heat exchangers, all that equipment is located inside the hybrid BC controller. So for those of you who are familiar with a typical heat recovery VRF system, there are piping limitations from the BC controller to each indoor unit that you have to be mindful of. You still do with the HVRF system, but those water pumps that are needed to get the water to the fan coil units are built directly into the hybrid BC box. So you don't have to have an external water valve or water pump to get your water flowing to a unit that's relatively far away from the hybrid BC. The only thing you won't be able to include inside that BC box is the expansion tank that you would need on the water side. But the water loop, it does need to be a closed loop, but it does not require any corrosion inhibitor. And from an installation standpoint, you very well may be able to use PEX or plastic piping. It's going to be dependent upon your local jurisdiction, the codes that you need to abide by, and the piping arrangement for your system. If you're trying to utilize this in a vertical stack configuration, you likely won't be able to use plastic piping. But if you're doing a more horizontal distribution across your building, it very well may be an option for you. Moving along, I told you I'd mention, or I'd discuss the carbon dioxide-based domestic hot water heat pump. I know many people are chomping at the bit for this product, and I'm not going to be able to make too many promises because it's still in the works, but with so much buzz around this type of product, I did want to highlight that we've had this for about 3 years in our European and Asian markets, and we are working tirelessly to bring this to the States. Kind of to reiterate what Kimberly said about being frustrated as an engineer needing products, just know that we bark this stuff up the chain and we beg and plead with our factory and give them as many positive business cases as we can come up with for why we need this product. And we're getting very close with the domestic hot water heat pump. So all the values that you see on the screen, if the KW didn't give it away, this is directly from the unit that we're shipping and have out on site in Europe and Asia. The unit we ultimately get in the US might be slightly different. We might get a little lower water temperatures, which would correlate to a little higher COP ratings. But the values that you see on the screen are going to be relatively close to the unit that actually comes out of the production floor. It's important to note that 100% nominal capacity down to 26 degrees Fahrenheit, that's the break point or anticipated break point for where the outdoor unit will start derating. So just like a normal heat pump, there is a point where the outdoor temperature gets so low that it becomes difficult or more difficult to pull the heat out of the air. And it's about 26 degrees with this unit. It doesn't mean below 26 that it can't work. We actually have a few systems installed in Norway that we put there for testing purposes, and they've been operating pretty flawlessly down to -31 degrees. So certainly more extreme than I'd ever see in my climate here in New York. These units, similar to the typical VRF outdoor units, are able to be interconnected on the controls side, and they can be cascaded together. So if you have a large heating demand for your building, you can connect as many as 16 of these units together in tandem to get you up above 2 million BTUs. The name of the game, though, with hot water heat pumps, and many people on this call are probably more familiar with this than I am, but the name of the game is really finding a good balance between generation and storage. So the more generation you have, or the more outdoor units you have, the less storage you'll need to satisfy your space. But the more storage you have, the less outdoor units you'll need. So it's going to be a function of your peak demands and what actually works for your building. But I do want to point out that although I don't have a storage tank shown on this, it is an integral and very important piece of the equation.
Just before you move on, because we definitely we're sidestepping any commitment to exact time to market, but I think at least to give you some idea, we do have these in field trials here in the US already. So this is not like way far off. Like we're getting close. Just can't give you an exact date yet.
So I'm going to breeze through so we can hopefully get to the Q&A and open the floor up to a lot of these great questions that I kind of see coming in on the right side of my screen here. But real briefly, we did release a couple new indoor units, or in the process of releasing, and have released one. The unit that you see on your screen is out now and available for ordering and designing and installation. So this is the new wall mount unit, which looks very similar to what we've had before. Any architects on the call are definitely loving this image, I'm sure. But the big benefit here, and the reason we're talking about it in a passive house conversation, is that we've extended the capacity range from a 1/2 ton down to a 1/3 ton. So we heard you loud and clear that lower capacity units are needed. So this 4 MBH unit, to my knowledge, is the smallest capacity VRF indoor unit that's on the market right now. So this unit is a few inches shorter. I'm not going to bore you with this eye chart of these funky metric to standard dimension conversions that happen here, but it's about 2 inches shorter and about 1 inch deeper. But now we have a 4,000 BTU option to hopefully satisfy small spaces a little bit better. The airflow distribution pattern was changed slightly on this unit to provide a more horizontal discharge. As you can see on the left side, the current, or now the old model unit, the discharge pattern was horizontal, but it was still angled to the point where it could maybe blow directly on an occupant, depending on the height that the unit was installed at. The new airflow pattern helps to avoid that direct blow scenario. Very importantly, the sound levels have been drastically improved. Not that these units were ever noisy to begin with, but they are substantially quieter now with this new chassis and the new construction, specifically on the 1 ton and smaller units. But as you can see, there's a 15 to 20% reduction in dBA, even on the 15 and 18 MBH unit. And the last product that we're going to talk about here today is the vertical ducted or multi-position air handler. We just extended the range from this down from 1 ton to 2/3 of a ton. This is a product I can't promise you a drop dead delivery date, but it is in the works and it is coming. It is being targeted at a 0.75 sensible heat factor ratio, which is better than most on the VRF side of things. Usually VRF systems live around the 0.8 sensible heat factor ratio neighborhood. So a 0.75 sensible heat factor ratio is an improvement. And what that does is it gives you more latent capacity for the moisture removal that we see as being critical in passive house projects. The unit was designed at 600 CFM per ton, which is a pretty high CFM per ton value. And part of the reason that decision was made was because this unit was designed with a whole apartment solution in mind. So this unit wasn't designed to really be a single zone space. It was thought about as serving the entire apartment, specifically for a passive house building. And when you start looking at passive house versus standard applications, if you will, the load profile versus the square footage is drastically different. So we wanted to make sure that this unit was moving enough air so that it could adequately reach and condition such a large space that 8,000 BTUs are going to. And part of the way that we got that sense, or that we're getting that sensible heat factor ratio down so low, is having an internal bypass circuit that allows basically inside the indoor unit for us to introduce some return air into the airstream before we bring it into the supply ductwork. It might seem counterintuitive off the bat, but in our experience, these systems are able to cool down a passive house space so quickly that you lose the dehumidification benefits of a DX system, where if we're able to temper those leaving air temps a little bit and make them more moderate, it'll allow the system to run in cooling for an extended period of time, not immediately cool down the space and deactivate the DX coil, but it'll allow it to bring some moisture out of the air for a more extended period of time. And I know I said that was the last equipment product, but I did just want to put a little bug in everyone's ear. We do have a new offering on the controls side that I think fits very well with Passive House. This is our energy apportionment diamond control panel. So for anyone on the multifamily side who's worked with tenant billing or energy allocation or energy apportionment, it goes by many names. This is a packaged plug and play advanced solution that allows you to accomplish that third-party HVAC bill that you might be familiar with. But some of the added benefits from this packaged solution that weren't available previously is 4G remote access to the system, and maintenance tool data becomes available even remotely. And what maintenance tool data is that's what contractors use to troubleshoot, diagnose, and service Mitsubishi VRF systems. So if you have a multifamily passive house building and there's a problem system or a problem unit, your contractor can log in remotely before they even roll a truck. They can look at the outdoor unit, indoor unit, DC controller, trended operating data, and they can have an idea of what they're walking into before they even pack up their truck and head to the site. So it gives a new window of information to the contractor or even to the building owner in terms of how the system is operating. And there's a customizable dashboard that comes with this that I'll show you on the next and final slide. And to support this product to the extent that we believe it should be supported, any Diamond Controls energy apportionment panel comes with factory startup and commissioning standard. So you'd have to kick us off the site. We want to make sure that this system is installed properly, up and running, and doing what it's supposed to do for you day one. And this is just a quick graphic on what that customizable dashboard could look like. Shows you on the right side how each room or zone is broken down and shows its particular energy usage, some trended data showing floor versus outside air temp, energy usage, floor to floor comparisons. You can really make this whatever you want, but I just wanted to show you what the graphics could potentially look like for you. And with that, we can move on to questions. So thank you for letting me bark at you for a few minutes.
Wow, fantastic. Thanks, you guys. And as I think everyone saw, we have a lot of questions. So we're going to dive into those, and I'll help facilitate that. If you have asked a question, and I'll be going through by order, but if you have asked a question, I encourage you to turn on your video camera if you can, just so that we see your face when you are asking for the info. So let's start with Galen. Galen, you had a question about piping system. So if you could unmute yourself and ask the question, we'll get you an answer.
Yeah, sure. So I was just wondering if Mitsubishi will supply a piping system or have recommendations for a certain piping system? Obviously, we could use whatever we wanted, but just wondering what Mitsubishi is going to offer.
What product in particular are you asking?
For the hydronic home runs.
Okay, Kimberly, I'm not sure that we have any plans. I know we sell the refrigerant line set spools. I'm not sure on the water side if we're planning on bringing any of that in.
Yeah, I have maybe a little bit of insight there. Hi, Galen. So I think what's likely is that we will issue, I want to say confidently, specific guidelines for application guidelines for design, but it's probably unlikely that we will be selling any sort of actual piping product. Maybe connections, but not likely. As we get more information, we'll follow up.
All right. Thanks, Galen. Okay, so next up is Justin Taylor. You had a question about how condensate would be dealt with.
Yeah, so I was just wondering, so for the first unit you showed for the heating and cooling, would the condensate within the system be dealt with the same way as you would for a regular mini split or VRF system?
Yeah, we don't.
Yeah, I don't know if it's okay to ask the other question I asked now, but do you see this possibly tying into an existing hydronic system? So you could like swap out a gas heater or something for heating.
So let me first address the condensate question. It's a simple yes. The approach is going to be pretty much the same that you're familiar with in terms of condensate removal from a mini split. The indoor units will have a built-in lift mechanism if they're at or above the ceiling level. So any ducted style units or cassette units will have a built-in lift. And then if that's not enough, or if you're utilizing a wall mount style unit, you'd want to consider a auxiliary condensate pump if you can't do a gravity drain system. And in terms of your second question, can you reiterate? I'm not sure I exactly understood.
Tying into like an existing radiator system within a building, like so if they're using they have hydronic system for heating in this building, and you could replace the boiler for that with this system. So you wouldn't have the indoor heads. You would just be tying into the existing piping system that's going to the radiators. So this would be only for heating, obviously, but just curious if you could see your system being used in that way.
So not the hybrid VRF system. I don't see that system being tied into an existing boiler hydronic loop, where it becomes a little tricky. I didn't bring any slides on it, but there is another product that we're trying to get to the States that pairs up with that domestic hot water heat pump that is designed to connect to existing hydronic infrastructure in a building. So I think that might be the product that you're thinking of, but that's not the hybrid VRF system.
All right, cool. Okay, so Foti, you're next. You had a question about certification. Are they PHI certified?
No, at this point, no, but that's certainly something we may look into. So cool. For now, no.
Yeah, got it. Great. Monty, you had a couple questions. You want to start out with one of them?
Hey, great to see you all. I'm going to ask just a couple questions about the hybrid system. I'm trying to get a sense of how the distribution would split between the VRF distribution and the hydronic distribution. Would you need one of those sub boxes like every floor, a couple of floor? Do you have a sense of how many units per breakout box would happen if we're talking about low load units?
So I can tell you that we anticipate the largest hybrid BC controller having 16 zones. So It's going to be a function of how many zones you have per floor. But yes, that's a great question with the sub BCs. That same layout that we do on the VRF side with heat recovery it's a very similar approach with the hybrid system. So yes, you could potentially use sub VCs to serve multiple floors or
Got it.
larger floors with more zones.
Have you compared the pumping power of pumping VRF and pumping water to the pumping power of just produced VRF? Is there a pumping power hit to be had because of this secondary system?
That's a question that I've asked our engineering team as well, and I haven't received a firm answer back yet. Kimberly, I'm not sure if you have any more insight, but it seems logical that it would give us a pumping power hit versus VRF, but I'm not sure.
Yeah, I guess the only thing I could add, I mean, you've got another piece of energy using piece of equipment, but like with our ground source equipment, the pumping energy, because of the pumps that we use, is not as high as you might anticipate.
Yep.
But it's
It'd be short. It'd be shorter distances.
Yeah.
And then two more. I'll be quick, Zach.
Yep.
Are you going to make heads to go with this? Or are you going to suggest we go get fan coil units or radiators in the market? Again, to this question of smaller heads. And then my last question is, does the outside unit for this system use a conventional refrigerant, or have you upgraded this to a low GWP refrigerant for the VRF portion of this system?
We, on the sales and applications side of the business, are pushing for at least the capability of utilizing a third-party fan coil unit. But no, we make our own, just like we do on the VRF side, our own coils, fan coil units to connect to. I'm not sure about the extended capacities in terms of the low capacities, but it would make sense that we would modify our product lineup so it's the same across the board between VRF and hydronic.
We need
VRF.
that 4,000. We need that 4,000 BTU one here too.
Right. Of course. And I'm sorry, can you repeat your second question?
Is the outside unit of this system one of the current refrigerants, or have you jumped into the next generation of lower GW refrigerants when you introduce this system?
So in Europe and Asia, it's an R32 system. So they've already taken a lower GWP approach. We're not entirely sure what we're going to get here in the States. I think it's going to be whatever the new refrigerant is, it's going to be basically the same outdoor unit. So whatever you use for your VRF system is what you would use for the hybrid VRF system. I can tell you that we actually have the only hybrid VRF system installation that's heating and cooling the Mitsubishi Training Center in New York City on 7th Avenue by Penn Station. And we have that connected to a traditional R410A VRF outdoor unit.
All right, great. Thank you. So we have a question from Faye Ruan about rated condition.
Yeah, hi everyone. Yeah, I just have a quick question about, I think you mentioned the COP is 3.88 for this product, and I just want to understand what's the rated condition in terms ambient temperature and the deliver temperature.
I don't know what the rated temperature conditions are, because we've said we've listed two different ones. So I'm going to have to wait for you to field this, Dan.
That's quite all right. It's a mouthful. Zach, Michael, maybe I could send out a follow-up to everyone showing. I have the brochure for the European version that shows all of the conditions that 3.88 COP was rated at, but it's all degrees Celsius and metric units on this cut sheet.
Absolutely. Well, I just shared a link, and I think that Michael shared the link earlier too to our community page, and we'll organize a center on that community page that's kind of centered around this presentation with more answers to questions and resources like that. So.
Could I interject here a quick question? I'd like to ask a question back to the crowd. How important is PHI certification to you all?
Great, and that's actually something that'd be great to, I see a very from Foti. Yeah, please respond in the chat. We can get some good information for the team here.
Great, thanks.
Awesome. Okay, so I think we have Zoe up next.
It was a long time ago, so I'm not really sure what I was asking. I think I was asking about a storage component. Dan, you mentioned a storage component that you weren't going to go into, and I was just curious to hear a little bit more about it.
And you were also asking about efficiency curves. Are there efficiency curves available?
Sorry, yes.
Yeah.
And
No. Both questions are great.
So yes, in terms of storage, really just high level. This is not like a true on-demand type of system. A boiler, you activate your gas burner and you're going to be pumping out hot water right from the get-go. And it's a little bit different with a heat pump system where DX is just inherently a little bit slower to react. So storage, in terms of a storage tank where you're keeping this water, just like the hot water heater at your house has, a few gallons of water that stays there. So when you flip the hot water tap on, you're getting it right away and not dealing with the delay from the system that's generating the hot water for you. It's really the same concept, just on a larger scale with this system. So since we haven't started applying this, I don't have a storage tank manufacturer recommendation for you, but this is not particular to only hot water heat pumps. There's likely storage tanks for many multifamily buildings, even that are using boilers, traditional boiler systems. And in terms of efficiency curves, we will have them, but we don't have them yet. We're currently in the process of testing this unit. We have field trials going on right now, as Kimberly said, but prior to the release of this unit, absolutely, efficiency curves, the testing data or the testing conditions for the US market, all of that information, like you might be familiar with other VR products, will be made available.
All right, great. Justin, sounds like your question was answered already. So let's go to the next. Andrew, I'm going to ask this on Andrew's behalf. Andrew Peel had to leave just a little bit ago, but he's asking, is 40 kW the only capacity available?
Yes, it's the only capacity available. So this is not a single family applicable product.
Got it. Okay, cool. And then is it Hayo, or you have a question about the what exactly prevents the CO2 unit from entering the North American market? So
yeah, I guess that is sort of like maybe a general question for all these units. I noticed that you mentioned a couple other units that are available in the Asian and the European market. I think it's this CO2 unit, and also the EcoDan, I think, is another unit. Just wondering why they are not available here yet, while they're already proven in other markets. And what prevents it from entering the North American market? Is it codes, or is it a market? The market itself, is there no how do you call it? Does Mitsubishi think that they can't sell enough here, or what? Yeah, what's going on?
Yeah, I could take that, Dan, if you like.
It's a great question. Have at it.
So it is a great question, and I'd say that there are a number of factors, but the primary reason has to do with our market, and it also has to do with prioritization in terms when we're dealing with a global manufacturer that has a number of markets. When you have markets like Asia and Europe who are much clearer and more narrow in their product requests, even if the market potential isn't as big, that clarity translates into getting the product that they're asking for faster. So another factor that's related to that is that we don't have any consistent policy that requires these increased efficiencies that we can deliver. And that's starting to change. And additionally, we're getting better at telling the story of the emerging market and making those market characterizations more compelling. So I hope that answers the question, but it is changing. And you can help us, so all of you can help us by providing us with project data. So past, current, and future project data. What kind of projects are you doing? What's how many units are they? Where are you designing them for? What are your specification requirements? You can send those to me, to Dan, to any of our team members, and that helps us tell that story in a more compelling way.
Okay, so it's not really, it's really more the market, but and not so much the building the codes that are preventing these units from being implemented.
Well, if we had the codes to require it, then we would have the market. So yeah, I'd say it is definitely the market.
Just maybe two things I'd like to add to that. I think Kimberly, you nailed it. I think we sometimes lose sight though of the fact that we do still have very low energy costs in the United States versus the vast majority of the world. So that's why these highly efficient products are demanded quicker and accepted faster in other areas of the world where, they may be paying 6 times what we are for electricity. It's more important, and the ROI is just a no-brainer in many of these other markets. And tangentially related to codes, the testing process for bringing products into the United States through UL or ETL, not necessarily that it's more challenging or more stringent than other markets, but it's another hurdle and it's a major expense. So that's why manufacturers don't roll the dice so much on products in the United States, because it's a very hefty investment. And the domestic hot water heat pump is actually a beautiful example. Without naming names, there's been a product brought to the market that's very similar to this product, and it came 10 years too early, and that manufacturer took the product away. It wasn't moving, but now the codes have changed, like you mentioned, and the market changed, and now you're going to start seeing these products come back. So it's a lot of things.
Awesome. Great question.
Thank you for the question.
Those answers. Yeah,
Thank you.
Thanks for those. So Albert, did you have a question about double wall?
Yeah, 2 questions actually, if I may, both very, very simple. Did I miss the hybrid system? Is the distribution in 2-pipe, or is it an option of 2-pipe or 4-pipe for cooling? And secondary was on the CO2 water heater, is it a double wall heat exchanger or not, I guess?
So I can tell you with complete confidence that the hybrid VRF system, it is only a 2-pipe. I think what you saw that was probably confusing was a bullet point that mentioned that you get 4-pipe capabilities out of a 2-pipe system. But no, it's you have 2 refrigerant pipes from the outdoor to the BC controller, and then 2 water pipes from the BC controller to each indoor unit. In terms of the construction of the domestic hot water heat pump, I don't know if it's double wall. We're going to have to circle back on that question. I'll get that answer from our engineering team though.
All right, we're going to move on to Paul Risto. Do you have a question? So on the large heat pump hot water system, are any integrated smart controls available or considered to reduce peak demand and preheat to move the peak load earlier?
I believe so. Just so I make sure I understand the question right, are we being asked if we basically have demand response capabilities with this unit to produce hot water during the best possible times?
Or predictive,
Joe says yes, demand response, and grid interactive hot water heaters.
Yeah, so I probably should have said this about a half hour ago. I apologize to everyone that I'm not able to give super firm answers. These products are still being tweaked and finalized. The final production models for the US are only determined for that little wall mount unit. Everything else is still being designed and implemented right now. So I have heard discussions about smart controls to accomplish exactly this requirement. We realize that certain jurisdictions have periods of time where energy costs are much lower, so it would be beneficial to be able to produce your hot water, let's say overnight, so that it's there in the storage tanks ready to go, rather than producing it during that building warm up, or, you know, the 6 o'clock to 8 o'clock slot where everybody's taking their showers in the morning. So there, I can tell you with confidence that the controls that you have seen previously with VRF systems, this system will operate on that same platform. So it'll be able to be integrated into the VRF system's centralized controller network. It will be able to be integrated into that Diamond Controls energy apportionment control panel. And I believe you will see the smart features that you're looking for when this unit rolls out.
Dan, I'll just add to that a little bit and say, you know, this is going to be a little bit of a different product because we do have the option of thermal storage, which is great. And so, again, this is a question back to the community. We could use your input. Our utilities team and our engineering teams could use your input if you're designing or already or planning to design with these kinds of systems. As Dan said, this, you know, a lot of the details are still in development. So now would be a great time to give us feedback as to what your requirements might be.
All right. So next up is Christopher Ham.
Thanks. I think my question was, what would the typical, this might be too technical, might be part of the what you send in the brochure, but do you know what the typical design leaving water temperature would be for the unit to provide heating and cooling with the wall-mounted units that you're producing now?
The hydronic system, the hybrid.
Yeah. Sorry, keep going.
And then the question was, I mean, does that vary? Are there sort of is there a typical leaving water temperature that you would set during cooling mode, or, you know, during the summer, and then a different one during the winter, or does it vary constantly?
So just like typical VRF systems, the unit is not designed to target a specific leaving water temperature or even a specific discharge air temperature at the fan coil. What it's designed to do is it either targets a return air temperature set point or a space temperature set point, and then the fan speed, the refrigerant flow, and now the water flow all vary to meet that either return air temperature set point or space temp set point. So your leaving water temps are going to vary, and it's going to be a function of the distance from set point in that particular zone, the style of unit, the different airflow settings that unit has, or the airflow setting that you have it locked into. So that's a challenging question to answer, even just on a standard VRF system, but it's going to vary is the short version.
Okay, thanks.
Thank you.
Great. We had a couple of questions about whether the presentation would be available later. We intend to publish the video of this presentation, but a couple of questions came through about whether the deck, the slide deck, might be available via PDF.
Dan,
so,
do you know if we can do that? We might have to get approval.
Yeah,
but
and we probably need
it. Approval.
We'll
right.
try.
We'll probably need to do
try.
the same. We'll need to do the same process probably for the video as well, I assume. But that's our intention. Okay, cool. So David White, you had a question about bypass airflow.
Yes.
So in a lot of my jobs, one of the biggest challenges is getting air from a bedroom or some separate room to go back to a central return. And usually there's a door undercut or a through wall grill and so forth. And the more airflow I need to get through that opening, the more expensive and the greater the expense. And so I'm wondering if there's a way to turn off the bypass airflow on the 8,000 BTU unit.
I was going to say, to my knowledge, sorry, Kimberly, there's no way to disable the bypass. There's not a 2-position damper that's going to change positions inside the unit. But you do have multiple fan speeds, and depending on your project requirements, I know the low fan speed, high fan speed's 400 CFM, low fan speed is about 280 CFM. So if your application doesn't warrant that high level of air movement, you can lock the system in to constantly running at a lower air volume if that has a benefit for your project.
Okay.
Yeah, so mostly what he said, but I'll only add that that will also decreasing the fan speed will decrease the capacity. So if you lock in to a manual fan speed, a lower manual fan speed, that will decrease the capacity, which a lot of times isn't a problem. But I thank you for your question, David. It reminded me to mention a benefit of that higher CFM. I acknowledge what, the challenge that you just described. But a benefit is that by having higher air volume move through that air handler, you do get increased filtration for a given space. So it's just a side benefit there.
And just to build off that, I know you had concern on the return side. That unit is still anticipated to have 0.8 inches of external static with the blower. So it's got some force behind it. It's not a weak fan inside that unit whatsoever.
Right. But I want to be able to return that air from the room to the corridor with less than 2.5 pascals of drop.
Understood.
Great.
Bigger door undercut?
Yeah, I can get 50 CFM out of it. Otherwise, it's a through-wall grill.
All right.
But I see it. And it does make the temperatures more uniform that way. If it's a single thermostatic zone, more air, that is helpful in that way.
Okay, cool. Well, thank you, David. Alejandro, you had a couple questions?
Yes. Some of them, I guess I wouldn't ask them anymore because it was in regards to about the storage tank, and I would like to see the whole system with the storage tank. Well, I have some questions. So if you're pulling, if you can pull, grab some energy and put it in a storage tank, is that will be connected to an indirect storage tank rather than a full tank to decrease any chances of Legionella?
Yeah, the hot potato. I don't have an answer for you right now on that one, Alejandro.
That's fine.
But it's a great question, and we can make note of it and get back to you on that.
Sure. And just last question. Already someone mentioned about the EcoPan, and I was very interested about those products and how they handled, how they work with the hydrobox and all that. Can you grab can you grab, if you have the storage tank and let's say you have some capacity limitations, can you grab heat from the tank and pull it back into your hydronic box to provide space heating in some, for instance, like a very cold night in a low temperature ambient? Is that possible? Like you can put heat in the tank, but you can also pull heat out of the tank and for space heating.
So the only system that we talked about utilizing a storage tank for is what's up on the screen right now, the domestic hot water heat pump.
Yeah.
And that's a high delta T system that you're not going to want to use for space heating. So the domestic hot water heat pump should only be used for domestic hot water heating or other high delta T applications. The unit that I kind of gave a teaser about that I said that works in tandem with the domestic hot water heat pump. Be on the lookout for something with a model number of CAHV. That's the low delta T product. Again, we've had it in Europe and Asia for a little while. That's that's the product that you'd want for a low delta T fin tube radiator type of retrofit scenario.
Let me just, I'm hugging this too much, but last question. If in a very hot climate and you're pulling chill water through the coils to cool the room, can you grab the heat coming out of those pipes and use it somehow, dump it into the hot water tank? Is there any ways that you can use some recovery in this system?
I don't know enough about how this system is ultimately gonna land from a design standpoint. I don't believe so. Where you might be able to utilize some heat recovery though is going to be on the hybrid VRF system. you might be able to, depending on what our factory releases for us, if we're able to connect to a third-party coil, we could have a separate zone off of that hybrid BC controller be kind of a dumping ground for any waste heat from the spaces when they're in cooling.
Good.
So that's where I think you might see some heat recovery on the water side.
Okay. Thank you very much for your time.
Thank you, Alejandro.
Thanks. Scott Kennedy, you had a couple questions.
I'm just wondering, for the outdoor water unit for the hot water system, are we actually running, is it a split system with a heat exchanger, or are we actually running water right into that unit? Because we've certainly had some issues with using CO2 outdoor heat pumps and freezing up and some issues there. So I was just curious whether that's been addressed.
So it is a self-contained system. You are running those two connections that you see at the unit right there in that image are water connections. They are not refrigerant connections. So all of the refrigerant is housed inside the unit. Like I said, we have had a system operating for quite some time in Norway down to the -30s, and we have not had freezing issues. The system does have a defrost cycle that it can activate as needed to shed any built up ice or condensation on the coil itself. So there's an internal circuit that's designed to prevent those type of issues, just like we do with the VRF heat pumps.
Yeah, and then does that also then defrost the lines? I assume you insulate the lines, the water lines, and then does it circulate water through the lines or something to deal with that?
I can't tell you for sure. I can tell you that the water lines are certainly going to have to be insulated. I believe that we're going to have to flow some water for that defrost cycle to happen. I don't know how far down the line you can anticipate an antifreeze cycle kind of working its way through there, but there's going to have to be water flow for the defrost cycle to happen.
Okay, and of course then we have a power failure problem, which has occurred to us as well. And then you don't have power to the unit, and then you don't have flow, and then you got a problem. So those are sort of problems that we have experienced, and just wanted to put those out there.
Oh, really appreciate the feedback on that, Scott. That's like Kimberly said a couple times. It's important for us to know what the designers and the implementers of these products are really looking for, so we can try our best to get these sort of functionality and requirements built into the unit that we bring to the States.
And then the last question I had was just when we do the recirc lines, because this is a high lift system and you have very small losses in the recirc system, are you going to have a unit specifically to make up those recirc losses separate from this unit?
I haven't heard of any discussion of a separate unit to be integrated with this, so I don't believe so.
It sounds like that unit you said coming with a C at the front would be kind of the kind of product we would need for that. But.
Yeah, that's where you'd be more in the 130, 140 degree water territory. I think I have some case study data. For those who are interested, please reach out to me. I think my email was up for a while. I'm happy to go over some of the applications where we have implemented these, even with the CAHV hot water heat pump, not the domestic one, the low delta T one that you're talking about. And maybe to back up to, I believe it was Alejandro's question, those case studies do have some one-line schematic drawings that show how the system was laid out.
Is your experience primarily with Sandin Systems, or is there another manufacturer that?
Certainly we're using Sandin Systems and we have solutions, but there are problems that come up that we're trying to keep solving.
Understood. Thank you.
All right, we have a question from Pierre Andre, and he does not have a microphone, so I'm going to ask it for him here. It's, what is the maximum distance between the outdoor unit and the interior box, horizontal/vertical? And what kind of protection does the outdoor portion on these lines need in very low temperature climates?
For the QAHV product or the hybrid?
I think he's talking for the hybrid VRF product.
Yeah, I believe so.
We don't have finalized engineering data yet for really any of these systems, but the hybrid VRF system, we're told to anticipate similar vertical and horizontal separation limitations, which makes sense because from the outdoor unit to the BC controller, it's basically the same system as our typical VRF heat recovery. So you can be 200 feet vertically separated between the outdoor unit and the BC controller. You get 300, 400 feet of pipe. It's going to be challenging to find certainly a horizontal run in a building that the system can't achieve. Vertical, depending on how tall your building is really the only thing I think you might need to be mindful of.
Great.
And then,
Thank
sorry,
you.
Zach, could you repeat the second part of his question?
Oh, yeah. What kind of protection does the outdoor portion on these lines need in very low temperature climates?
I think what he might be asking is snow and hail guard accessories, kind of low temp protective accessories that are available for the outdoor unit. If I'm not understanding the question right, I apologize, but it'll be this, since it's the same VRF condensing unit, it's the same requirements that we have and the same accessories that we have on the current VRF units that we use in cold climates. So there are angled deflectors on the sides and the back that protect the coil not only from hail or snow buildup, but they also help prevent cold air blowing through the unit. And then there are a couple different hood configurations for these outdoor units that either are there to prevent snow buildup inside the fan that's on top of the unit, or to recirculate air for low ambient cooling applications.
All right, David Solomon, you had a question?
Yeah, thank you.
Yeah.
So let's see, the first question, you sort of actually just you answered so similar to the last question about the line length distances, but for the heat pump, is there a limitation? I think it's like with the Sandon, right? It's like 25 feet between the heat pump and the tank. What kind of limitations are there on this heat pump unit for the domestic hot water?
I don't know off the top of my head. I'm looking through the cut sheet that I have right now to see if it's shown here. I don't believe it is. We'll get you that info.
Okay.
But generally, I mean, the general response, Dan, stop me if I'm wrong here, but is that it'd be considerably longer than that 25 feet.
Absolutely. Absolutely.
Yeah, I would imagine for a centralized system.
Yeah.
Like
Yeah, I don't know what the limit is, but I will get that for you.
Okay, thanks. And then my other question is just, can you give us just a rough estimate of the cost delta between the hybrid VRF system and a comparable, normal VRF system? Clearly there's, is it the same? Is it twice the price for half the global warming potential? What's the...
I'll give you my canned answer. Unfortunately, we don't have price books yet for this product. But the nice thing is we do know what the outdoor unit is, and we anticipate the indoor units being very similar. It's just a DX coil becomes a hydronic coil. So really the difference lies in that hybrid BC controller. So this is going to change depending on how big the system is, because there are so many more constants the bigger the system is. Mm-hmm. But we anticipate between a 15 and 20% premium on the equipment side for the hybrid VRF system. But got to keep in mind, there very well may be offsetting installation savings if you're able to replace brazed copper refrigerant piping with PEX. You also might be working with a different contractor even than you were with the typical VRF system. Now it's a plumber rather than a specialized HVAC contractor. There are a few things in play, mm-hmm. but ballpark 15-20% upcharge on the equipment cost.
Okay. And I apologize if you said this and I missed it, but is there a timeline for getting this equipment to the US market, or is it like how far out are we ballpark? So
I can tell you that the wall mount units are here already. The other 3 units, the QAHV domestic hot water heater, the hybrid VRF, and the PVFY, we are anticipating all 3 of those products in 2021. It's hard right now to say when in 2021. If I were a betting man, I would say summer. But I hope I'm proven wrong and it's January 1st.
Thanks. I appreciate your time today. Both
Thank you.
Thank you.
Awesome. Hey, Kimberly, could you advance the slides so that we can, everybody here can see your email addresses?
Oh, sure.
I know some folks are
Let me see.
eager to see that. And I'm not sure if Monty's still here. Monty, if you had another question, please feel free to ask it.
You covered most of it, but as you've discussed, I have a new question. I assume you'd want to put that jump box where you're converting from the VRF system to the hydronic system in a public space rather than in an individual unit, so that there's no risk of the higher level of refrigerant draining into a bedroom or something. Is that a correct assumption?
That is a very correct assumption. Yes, you would want to put that BC controller in a spot where you're not, the larger the space, if you have a mechanical room, I think that'd probably be a beautiful spot to put it. Somewhere where the total refrigerant for the system, that amount isn't going to cause you any ASHRAE 15 headaches.
Thanks. This is a great presentation. Really appreciate you all making the time.
Yeah, thank you. And actually, I don't know why you just made me think of this, but an interesting application I saw recently for the domestic hot water heat pump was just like we've done with our VRF condensing units, our air source VRF condensing units. I saw an application where the QAHV domestic hot water heat pump was installed indoors. And it was the exhaust air from those units were actually used for something. I'm not exactly sure what they were cooling with it, but they were using that exhaust air from those units being indoors for another process in the building. So kind of backing up to
room or something.
Backing up to that heat recovery question, it's a kind of intricate way they came up with to do that.
Fantastic! Wow, we made it through the questions. That was quite the list. Fantastic, thank you. I'm going to throw it over to Michael.
Well, thanks again. Yeah, thanks Mitsubishi. This was a lot of fun. You guys were great with the questions. Again, for everybody who hasn't been to the Q&A page, sign up. There's been a few links in the chat. Some of the questions and answers will be published there, but it's also a great place to ask more questions and even answer a few. So it's a lot of fun. And thank you guys again for
spending
the
so much for having
afternoon
us.
with us. I appreciate it.
Thanks everybody for your time. Look forward to hearing from you.
Thank you so much. Yeah, please don't be bashful. Please reach out.
All right. Farewell, everyone. Thank you.
Okay, bye.
Have a great weekend.